Hello, my name is Andre Roberts. This is for Lab 2 of the IoT class. I'm going to start this video with a report for the Pi car and how it communicates with the communicates through Wi-Fi to the laptop that will use a web interface to control it via the Wi-Fi connection. So I will just describe how this works, and then we can demonstrate it and show how the web interface works and the code for that as well. So really simplistic, as we've had before, and forgive me, I'm using a TV as a monitor, so I will try my best to show off what we have here. Very simplistically, it uses a socket interface that was kind of given to us as an example from Caesar's code, where we use the Raspberry Pi's host IP, and we pick a port to basically listen to. As long as it's available, it'll work, and it waits around for any information that's being sent. We decode that information in the message section here. Let me see if I can highlight it right here. And basically from that point on, it's a matter of seeing what that information is. So if it's a numeric value, we know that we're trying to set the power value of how fast the car can go, or if it's command move forward, left, right, down, and otherwise we have it displaying info on command, and it will also display info anytime other commands are finished. So very simple code here. So now we can kind of go over the website code and the way it works at the web interface. So we'll go into the example of what we use for the code for the front end. Very simplistic. Won't go over too much of certain elements, especially the HTML and anything else related to it, because it's obviously coming from mostly from Caesar's example code. Just a little bit modified to include more elements like explaining the power, direction, distance, and the grayscale list that we can get. The main important part, obviously, is the part where we communicate to the server that is the Raspberry Pi. So the idea is, we get whatever command we need to, and we go to this client function here, where with the server port and address, we try to make a connection to that server and go and write something to it. And what that'll do is, from the previous code shown, it'll take that data right here from the input, and it will run the commands as given, and then later on at the end of the command it will receive data when the client sends it back, or sorry, when the server sends it back to the client. And then from there, that's how we can show off stats like the power value if it's moving in a certain direction, and there's a few things we have to kind of manage with due to some issues with using Python and trying to figure out exactly how to represent the information the best way. So nothing too important, but the general idea is that we are using all of this parsing and everything to get all the correct values for see if it's moving at all, if it's not, and then trying to determine the distance and the grayscale from all the from what we can get from that buffer. Very simplistic, and it'll terminate the connection so it can do it again, and that way it's not hogging up the connection for to avoid any issues causing multiple calls. So it's running right now. We have it right here, and you can see we have the sorry, The website pretty much as built before. Nothing too special with the UI, mainly because I had to do this project alone after my previous group didn't wasn't able to be work with. So I focus mainly on functionality. Everything still works as intended, and I'll start demonstrating that right now. Alright, so I'll start with showing off it just starting up from the very beginning. I will give it some new information to work with. So here I can either give in a command or just the power value. It's normally set at zeros, so I'll put it at, let's say, 10. Command is 10, and we get all the inputs back. So right now it notices it's at the power value of 10 that I just set it at. It's not detecting any obstacles ahead of it because right now it's currently a little too far away from anything, as you can see. And then we just have to grayscale this, see if it's near any kind of cliff or anything like that. So we'll keep going here. So just to note, I had to hastily build my Pi car because, again, I'm doing this project solo, and my Pi car wasn't working before, which is why I did get into a group from my previous lab, and then now I'm without a group and with a poorly built Pi car that has a lot of issues. So I had to rebuild it really quickly, and one of the tires doesn't work, or one of the motors doesn't work with the tire, so this is as best as I could do. It still works for the functionality and what this lab's purpose is. So I will demonstrate that when I hit something like forward here, I just press the button and it moves. I only have it moving in small increments because, again, it's not very good with keeping the tires on, with the missing a tire, rotor issue, all that. But I'll keep pressing forward, so forward, forward. I can do right, and you can see it's capturing data. Sorry, I just wanted to fix a small minor bug that I accidentally forgot to change how to determine if it's idle for it's actually moving right, left, or down. Didn't want to redo the video because it is a long 10-minute video. So very simple. Like I said, it can move any direction. So I'm gonna go forward, forward, left, left as much as I can. Forward. I can even turn up the power here. So as you can see, it's been gathering data every time. Let me put the power up to, let's say, 50. All right. And now we're gonna go forward a lot faster. And again, you can hear it, and it is working. For each function. So it can move forward, left, right, and backward, and it will display that data every time you input a command, or if you just even want to see a command. So like, let's say if I move this car here and I wanted to move it, where's the best place? Let's just say next to this wall. So I wanted to just see if it notices that it's something right in front of there, and I put info. Yes, so you can see from the distance it notices there's something right there, so you could use that kind of data for more advanced ways of saying, hey, you should stop here. So as you can see, it can move, it can go backward, all sorts of directions it needs to, change the power value, can get the grayscale list, it can get everything you need, and this perfectly demonstrates how the Wi-Fi connection between the Pi car and the laptop we're using can work successfully. So this is successful Lab 2 with a good front end to use. Very simple, but it works. Thank you. I will show one last thing. And just to show, this is the Pi terminal showing off exactly that. It is communicating all of those directions, and then is also sending back information for each command. So thank you. Have a good day.